I've made several unsuccessful attempts at this video. It came from a student email asking me to explain asymptotes, intercepts, and locator points. I started by writing and talking as I write, and I realized that not only were my words a bit scattered, but the mic on my computer was picking up every single click of the keyboard. It sounded kind of like listening to fingernails on chalkboards. Chalkboards are this thing we used to have, before whiteboards, back in the days when we would ride our horse and buggy to school and had a hamster run around on a wheel to power our calculators. I didn't want that sound. So I decided maybe the best way to do this would be to record my screen as I talk through it, then transfer that file from my Surface Pro to my MacBook, then erase the audio and create a new audio file where I act like I'm a sports commentator analyzing what's happening in the video. Oh, and by the way, have I told you I have an old student who writes poetry? Her name's Shirel. She's an inspiration to me, and you can check her out on the internet. Here is one of her poems from her book Comfort Zone that seems appropriate for both math and distance learning. Okay, so here we see a standard notebook with the title that says Intercepts, Locator Points, and Asymptotes. We have not seen a whole lot of action on this screen yet, and we believe that at some point things are going to, oh, he's clicked the highlighter, he's highlighted the intercepts line, he's moving around screens, now he's back to the window, he's writing the word which appears to be intercepts, and he's underlined it. Now he has drawn not only an x-axis, but a y-axis, and here he goes, oh, red, he's drawn a linear line in red, folks. And what do we have here? We have a y-intercept and we have an x-intercept. Oh my goodness, now he's labeling the x-intercept and he's labeling the y-intercept.
Yeah.
And now he appears to be erasing everything that he just drew. And what is he going to do now? Oh, it appears that he's showing you how to solve for the intercepts algebraically. I assume that he'll first start with the y-intercept. It's a bit less tricky of an operation. Let's see, what's he going to do here? Yep, that's exactly what he's doing. He's starting with the y-intercept, and he's going to plug 0 into x, because that's how anybody would solve for the y-intercept. And let's see, when he does that, he gets y equals negative 18. And I believe that that's the correct answer, isn't it? Well, let's see. Oh, he's added the extra detail of the x location too. So he's added 0 comma negative 18. Now it's brilliant. And now he's going for the x-intercept. This is a much trickier thing to do, so you have to pay attention while he does it. What's he going to do? Oh, he's not plugging in 0 for x. This time he's plugging in 0 for y. Now, how's he going to solve this? What's he going to do to solve this? I have no idea. We'll just have to, oh, he's moved 18 to the other side of the equation, and he's divided both sides by 2. And now he's determined that x can be 3 or negative 3. And I assume he's going to write the complete x comma y location. Yeah, that's exactly what he did. Exactly what he did. 3 comma 0 or negative 3 comma 0. We have a professional here.
I'm different. Yeah, I'm different.
Back there, and he's added the y-intercept, and he's even labeling it 0, negative 18. Oh, and what's he going to do now? It looks like he's labeling the x-intercept 3 comma 0 and the other x-intercept negative 3 comma 0. I bet he's going to use this to draw a sketch of the graph, and that's exactly what he's done. It's an upward-facing parabola, and you can see it right there. He's used the intercepts to locate the approximate points where the graph should be. And now what's he doing? Now he's going to Google to look up the term locator point, and he finds it in the CPM glossary. This must just be a term that CPM has introduced that's not part of the traditional math vernacular. There it is highlighted right there. It's a point that allows you to locate where the graph of a function is. For a parabola, the vertex is a locator point. This probably is not a term that you need to worry about seeing on tests or quizzes, but it is an important concept in graphing functions. And now he's flipping through Windows. He's clearing some stuff out of Desmos, and he's adding in a new equation. The equation says x minus 3 squared plus 1. Oh, there we go. There is a standard form, vertex form of a parabolic or a quadratic equation with, yep, there's the locator point. The vertex is at 3, comma 1. And now he's erased that function and he's adding a new one. Y is equal to 4 raised to the x. So you have an exponential function that's always going to cross through the y-axis at 0, comma 1. So I guess he's showing you that the locator point for an exponential function could be the y-intercept, which is always going to be 0, comma 1, unless it has a leading coefficient. He's playing around. Okay, so now he's added a 3 as a coefficient on the exponential function, and he's showing you that the locator point is at 3, comma 0. Now he's switched it to negative 3 and shown you that the locator point is at negative 3, comma 0. Sorry, that would be 0, comma negative 3. Now he's flipping back through his windows. He's back on the notebook. He's back on Desmos. He's erased his equation. And what's he doing next? He's adding in a new equation. Y equals 1. Just a horizontal line. Oh, 1 over x. Okay, so it's 1 over x minus 2 plus 3. We've got here a rational function, and maybe he's going to show us what the idea of an asymptote is. Let's see if that's what he's going to do. He's moving the graph around a little bit, and now he's entering z, nope, not z, x equals 2. There, that is what he's doing. He's showing you a vertical asymptote, which is a line that the graph approaches infinitely but never actually touches. And he's made it dotted because that's typically how we see asymptotes. And he's showing you how the graph actually never hits, the dotted line actually never hits the graph. He's made it orange and he's made it dotted and he's made the graph black. And now what's he going to do? I bet he's going to add the horizontal asymptote. Let's see if he adds the horizontal asymptote next. There he is. He's going back to the screen. He's adding in y equals 3, and there we go. You can see the horizontal asymptote. So now, of course, he's going to make that dotted, and keeping with convention, he's going to make it orange also. Now he's getting rid of everything. He's going to show you something new. I'm not sure exactly what he's going to show you here, but clearly he's showing you the vertical and the horizontal asymptote. So what else could be left? I don't know. He's entered x minus 1. He's entering x plus 2. He's added a denominator. He's made it x. It's clear that there's a vertical asymptote there at x equals 0. But we've already understood the concept of vertical asymptotes a little bit. We'll, of course, talk about it more, but he's showing you that. He's putting it in orange, and he is now, what's he going to do? He's turning it off. Okay, so he's showing you another, oh, he's adding you the line y equals x, which looks like it could be somewhat like an asymptote here. Yeah, he's added y equals x plus a. Oh, he's added a slider. I wonder if he's going to slide the slider until you find out where it does appear that there's some kind of an asymptote that's not either horizontal or vertical. Maybe that's called the slant asymptote. Yeah, it appears that he's showing you that in some cases there's even a slant asymptote, which is not vertical or horizontal, but it's a line that the function approaches on either side that is still considered an asymptote. That's brilliant.